Question 4 is really tricky, so let's get to it right away. Two objects, both of mass m, are free to slide with negligible friction on a horizontal surface that lies in the plane of an xy coordinate system. Initially, one of the objects moves with a velocity v0 in the positive x direction and towards the second object, which is at rest. The two objects interact for a brief time with no net external force acting on the two-object system. After the interaction with the first object moves with a velocity that has positive x and y components of velocity, a magnitude v0 in its direction, in the angle theta from the plus x direction. What are the final x components vx and v and y? A component of vy of the velocity of the object that was initially at rest. That is what we call in the business a word salad. So if you look at the answer key, all the x's are different, so let's only focus on the x component. So momentum initial is going to be momentum final. That's a conservation of momentum. So let's see that. mv1 is going to equal mv2. We know that this is going to be just mass, and the initial velocity is just 0. That's given to us. Now, this is going to be a little bit tricky. We're looking for Vx, so it's going to equal Vx plus, we can use some trigonometry. We can look at this to figure out its V0 cosine theta in that direction. So it's going to be V0 cosine theta and m, running out of space, and that should be m2 because momentum rules. So we can first eliminate all the m's because we can divide it all by that. So V0 equals V cosine theta plus Vx. So subtraction equals Vx. Oh, that's a little bit messy. And then we can factor out V0 to get 1 minus cosine theta equals Vx. And if you look at the answer key, that is the correct answer. So that's what you do to solve this problem.